Here we go. So, first of all, you have the notes on your desk. We're going to be working on the notes and the worksheet. Now, you know I never really use those notes the other teachers use, because, all right, so it says find FOG of X. So, this was just a problem you did on the whiteboard. What I want you to do is do it on the whiteboard if you haven't. Okay, everybody watch. Make sure you did it right. So we know that f of g of x really just means push x back in with g. That's g of x. Push it back in again. So that's f of g of x, right? So that means you're plugging in function g of x. Okay, there's g of x into function f wherever there's an x. So that's replacing x. So that's going to be, instead of an x minus 1 squared minus 3. Now let's put it in standard form. We know we can't break the forbidden rule, x minus 1, x minus 1. We would double distribute. I'm confident you can do that correctly. So you have x squared minus 2x plus 1, correct? We can't forget about our minus 3. So then we combine like terms. X squared. Now you guys knew what I was doing when I said double distribute, right? Okay. So we have x squared minus 2x minus 2. Questions on that? Okay. Moving on to today's lesson. So, today we're doing 7.1. We're going to be graphing cubic and other radical functions. So, some vocabulary to remember. So, what I want you to do is flip into your notes to 7-1. This part is not on your notes. We're going to be bouncing all over the place a little bit. So, these are things we've seen before. So, some vocabulary to remember. If I say to you parent function, remember that parent function means it's the most basic non-shifted function. So every single function has a parent function, a non-shifted function. So these are just examples of a bunch of different types of parent functions. That means non-shifted basic functions. So everybody just look, you're not taking notes right here. Y equals x is the parent function for a line, non-shifted, basic function. Y equals x squared is the parent function for a quadratic, right? Does everybody see how they're all basic? Y equals x cubed, y equals the square root of x, y equals the cube root of x, and y equals the absolute value of x. Those are all parent functions. So, one thing to note, functions that have shifted from the parent function will only have one variable. So not all functions are written as a shift from the parent function. So let me show you an example of what is and isn't. So looking at, I'm going to scroll up with the people in the back. Looking at these two examples, do you see how this equation is a shift from the parent function y equals x cubed? There's only one x, correct? So that would be considered a shift from the parent function. However, this is not a shift from the parent function because there's two x's. So that is a cubic, but it's not a shift from the parent function. Everybody understand? Okay. All right, so this is where you want to take some notes. So write it on top of your notes or whatever, wherever you want. So remember that shifting, once you know how to shift one function, you know how to shift all functions. It always works the same. So shifting for all functions from the parent function works the same. So just a reminder of our different shifts here. So I'm just going to explain what this means for a second. We have f of x is equal to, so that means we have a function that's equal to, this reads negative a, and then we have f. Now notice that's not a function, like that's just saying we have a function. So that's not x squared, right, everybody? Like that's just any function, and then if you have an x minus h plus k. So you're going to be taking, and this is how the shifts will work for all functions. So that just means you take the function. Does that make sense, everybody? Any function, this is what it's going to work. So this is how the shifts work. Just a reminder, anything grouped in with x is your shift left and right, and we go opposite of the sign. Correct, everybody? That's not new to us. So this would be a right shift of h, right h. Does that make sense, everybody? That's what shifts your function left and right. Now this plus k is what shifts your function up and down, and the sign stays the same. Questions on either of those? Okay, next thing, we've got to just look at a, not the negative, just a. A is what you're multiplying in front of the function f. In front of the function, whatever you multiply by is considered a stretch or compression. Now, one thing I need you to picture in your head, I'm going to put that there for a minute, is this is a stretch like this. If you took a rubber band and stretched it like this, it's a vertical stretch or a vertical compression. Yep. So when I say we take the function and we stretch it, I mean vertically. Does that make sense? So if a is greater than 1, like 2, it would take and stretch it up this way, up 2. Does that make sense? The acceleration gets larger quicker. So it stretches it this way. If it's less than 1, it compresses it because the acceleration is less, so it compresses it down this way. So stretch or compression. The negative in front of A, if there's a negative, it's its own transformation. That is considered our reflection over the x-axis. So that's what takes our, like, for example, our quadratic, that's a smiley face, reflects it over the x-axis, and it becomes our frowning face. Does everybody see how it's just reflecting them like this? So that's what that does. It's a reflection over the x-axis. So the first thing we're going to do is we're going to be given a parent function, we're going to be given a shifted function, and in words, we're going to describe the shift. So look at my first example here. This is the shifting. You have to be able to at least word it correctly. So looking at this parent function, y equals x squared, let's describe in words the shift. Ready? So we would say, right 3, you go opposite, right? Up 2. True? Stretch, don't look at the negative. 2 is greater than 1, so that's a stretch by a factor of 2. So I'm just going to say stretch of 2. And then the negative will take our quadratic and reflect it over the x-axis. Questions on that? Okay, I want you guys to describe the shift from the parent function. Ready? And you guys just shout it out. You don't need to write it down, just shout it out. If this is the parent function, y is equal to the absolute value of x, what was my shift here? Left 1, down 3, compression of 1/2. Questions on that? Okay, x cubed is our parent function, so what's my shift? Shout it out. Right 4, up 5, stretch of 3, reflection over the x-axis. Okay, good, we get it. So y is equal to the square root of x. This would be a shift of right 5, down 3, and a compression of a third. You guys are awesome. We're almost there. So y is equal to the cube root of x. Describe a shift. No, shift left and right. Up 3, stretch of 4. Now look at the line. Y is equal to x. This would be considered a not a trick question. All the other right 3, right? Stretch of 2. Reflection over the x. Okay, perfect. So let's go backwards. This is the important one. This parent function y is equal to the square root of x. We're going to write an equation for these shifts. So this is our parent function. Let's go through. So stretch of 2. Isn't that what's multiplied in front? Guys? Yes. Okay, so 2 square roots of x. Perfect. Check that off. Now reflection over the x-axis. What do I need to do? Negative 2. Questions? Right 3? Right 3 is plus 3, so shouldn't we put minus 3 like you said? Okay, very good. Down 1, that's added out here. Okay, you guys have got it. So you guys do the next one. Write it on your whiteboard, hold it up. You guys said 1/2 x cubed plus 3. Now, a lot of you had this, which was also correct, 1/2 x cubed plus 3. Notice, because we could just write it like this as well. Does everybody see why? Same thing, right? Do one word. Okay, you guys go for this one on the whiteboard, all right? And do that. So you just go in sections. It's a cube root. So y is equal to cube root. We have our x, and then stretch 3, like you just said. Boom, boom. Yes, like you said. And then left 1, shift left and right going here. So that'd be -1, so that's +1. You guys got it. You're awesome. Okay, let's see if you can take that, twist the linear, and do it. So write it out big on your whiteboard quickly. Move on to the next one. We got it. Okay, now this is what I have seen on ACTs and envelope types. They want you to apply that to a general function f of x. So it's not a quadratic, it's not a cube, it's just any function. You see how it says f of x? I want to see if you can write it and use your logic to write this out correctly. Notice it's using different wording, but think about it. Okay, go. So a lot of you are really, really close. So f of x is the function, correct everybody? F of x is the function. So we have y is equal to, we have f of x, okay, so we have our x, and then we're shifting stretch of 3, so that goes in front, horizontal shift, 4, -4, And then minus 2. But do you see how I have to have the F there? Otherwise, it's linear.
Oh, F outside.
Yeah. Yeah. Horizontal is a shift left and right. Isn't that positive 4? So if it went in the fourth direction, I'd be this way. Does that make sense? It'd be opposite. Yeah, you're right. Correct. Don't write it as linear. Okay, good. All right, what I want you to do is go to your homework worksheet, and you're going to get these problems done. 1 through 4, check them with me. And then if you get that done, go to the notes packet and do problem 1 and 8. But do your homework ones first. Go to your notes quickly. Open up. What we're going to do is we're going to graph parent functions, and then we're going to graph shifted functions. Every year I teach this differently because I never quite know what's the best way because there's so many good ways. So I'm going to show you a couple different ways to kind of do this, and then you're going to have to be able to do it one of the ways. You are not allowed, during this time, you would not be allowed a calculator on the test. We want to see if you can do it by hand. Does that make sense, everybody? So, pay attention. Focus. So, we're going to, first of all, if you know what the parent function looks like, you know what the shifted function looks like, right? We just shift it from the parent function. So, what we're going to do is we're going to create a parent function here. So, y equals x squared. Now, remember, if I put something in, I get something out. So, let's plug in some points here. So, if we plug in -2, what do we get out? -2 squared. 4, right? We plug in -2 and get out 4. Let's plug in -1. -1 squared is 1. You should be writing down these points on your notes. There's a place on your notes. Okay, let's plug in 0. We get 0. Let's plug in 1. We get 1. Let's plug in 2. We get 4. So do you see how I created those points? I literally just plugged in some random values. So that's enough. Let's plot those points. So you'll go, I'm going to start with -2 at 4. Boom, there's a point. We're going -1 up 1. There's a point. 0, 0. So you're plotting this exact same thing on your notes. Yeah, perfect. You're on the right spot. Over 1 up 1. Over 2 up 4. So this is the parent function. A couple things to notice about the parent function. Okay? Notice, don't we start at the origin, this bottom point here? 0, 0. Now, don't you know, so notice a couple things. Do you see how we're going over 1 up 1? Over 1 up 1, yeah? Okay, so now if I shift all those points, it's just going to look the same but shifted, correct, everybody? Okay, awesome. So let's use that information to shift the function. So you don't need to take notes during this part, just watch, okay? So there's 2 ways to do this. What we're going to do is, we have the parent function graph here, y equals x squared. Can you all see it? We're going to go ahead and shift it, what? Right? 5, down 3. So watch how easy this is. If I know these original points, I can literally start here and shift it right 5, down 3. Boom. Does everybody see? Take this next point. It's going right 5. So right 1, 2, 3, 4, 5, down 1, 2, 3. Everybody good? Same thing here. Right 1, 2, 3, 4, 5, down 1, 2, 3. Okay, it's making sense. Do you see this? So, yeah, we're just shifting it, right? 1, 2, 3, 4, 5, down 1, 2, 3. Same here, right? 1, 2, 3, 4, 5, down 1, 2, 3. Okay. So let me show you algebraically what happened here. Because I might say to you, what are the new x? So I might have you watch what you could have done this way. So watch. We shifted right 5, so isn't that taking your x values and adding 5 to them? Right, everybody? Please focus and participate. So we could take all our x values and add 5 to them. Now, we're shifting down 3. That's a y value shift, correct? Everybody? So we could shift, that was subtracting 3 from all of my values. And then I would have my new x, y points to plot. So we would have 3, 1. Isn't that a point? Over 3 up 1. Do you see how this produces a new point? Pretty easy, right? That's what Mr. Roberts makes his honors class do. Write out the new x, y point. Like I said, there's many ways of doing this. That's why I always debate what's the easiest. A lot of times it's almost easier because you'll see what I mean. So here and there, but that was pretty easy, right, everybody? So I want you to do the easiest way possible for you. So here we go, as long as you show your work. So with this one, now we're shifting left 4, correct? Left 4, up 5, right? Is anybody confused? Okay. This is just an example that's not on your worksheet. So I'm just giving you examples of shifted functions. So you're just watching. So here's the thing though. We also have a reflection over the x-axis, right? That is always the first thing you're going to do. So let me show you how this works. That would be taking this point, and instead of going to right one, up one, we're going to take and reflect it over the x-axis. So that would put us down here, correct? Right one over one. Isn't that reflecting it over the x-axis, everybody? So do you see how it didn't change any x values? It only changed my y values to be the opposite of what it originally was. Opposite sign. Does everybody understand? So we could do this with all of our points. So this one would be hard to like regraph and then go. So this one's almost easier with new points. So I'm just going to use algebra to get new points. So watch. The first thing you do need to do is multiply by this a value to your y values and only your y values. So you take your y values and multiply them by -1. So what am I going to get? -4, -1, 0 times -1 is 0, -1, -4. Does everybody understand? Now, we're shifting those points. We've reflected it over the x-axis. So now, we could shift them left 4, so we could subtract 4 from x, correct? So I just talked about y, so that's a really good question. So watch what happens when I reflect it over the x. I still go right 1, so my x value stays the same, but instead of going up 1, I go down 1. So it only changes your y value. Does that make sense? Because it's only reflecting it this way, so that doesn't change where it is left and right. Does that make sense? Right. Okay, so now we could go through and we could subtract 4 from all of those values. And then we're going to those values, we're going to add 5. So isn't that a y shift, guys? So add 5, add 5, add 5, add 5, add 5. So let's write out our new x, y points, everybody. Here we go. -2 minus 4 is -6, correct? And then we have comma 1. -5, 4, right? -4, 5, -3, 4, and -2, 9. Okay, let's graph those points. Oh, that's a -4 though, right? So that's a 1. My bad. Okay, here we go. Let's plot those points. So -6 up 1. Boom. There's a point on our graph. -5 up 4. -4 up 5. -3 up 4. Okay. And -2 up 1. And boom, there's my upside down parabola that's been shifted. So do you see how that was pretty easy for the most part to do that? Let me show you another way to do it. Let's say you like this way better, and then from here on out we can do it that way. See, tell me if you like this better. So the first thing I do is I always do multiply my y values by that a value. So what does that be? So watch, everybody. So 0, what's 0 times -1? Still 0, correct? So this would stay there. Then we're shifting it left 4, so we're going back 1, 2, 3, 4, and up 5. 1, 2, 3, 4, 5. Boom, it goes there. So this one, the reflection would be starting here, correct? So then we'd go left 1, 2, 3, 4, up 1, 2, 3, 4, 5. Do you like that way better? So I started with where my reflected point would be. So wouldn't this reflected be right here? And then I shifted left 4, back 1, 2, 3, 4, and then we went up 5. Up 1, 2, 3, 4, 5. So I knew that point went there. Do you see what I'm saying? It's just doing this, but not having to write it out. But you would be able to write it out, right, if I asked you to? Okay. Let's do this one. Here we go. So focus. We're kind of going slow. So what we would do is this is a stretch of 3, correct? And then a reflection over the x-axis. So what we're going to do is multiply all of our y values by -3. That is where I'm going to start, for sure. Times -3, times -3, times -3, times -3, times -3. So my new point so far would be starting at -2, down 1, 2, 3, correct? And then are we shifting down 6 more units? Does everybody understand what I'm doing, or is anybody confused? Okay, so let's write all our new points then, if you're confused. So our new points are -2, -12, right? -1, -3, guys. 0, 0, right? 1, negative 3, 2, negative 12, right? Then I'm just shifting those now down 6. So we're going to start at those, so then subtract 6, subtract 6, subtract 6, subtract 6, subtract 6. So we have to shift up and down. Is anybody, are you still confused? Okay, perfect. Okay, if we're good with that, then let's just move on to the next one. Okay, so next parent function is this. Go to your graph, quickly. So we're in our notes. Y is equal to the square root of x. This is in your notes. You should be starting here. We're going to list out a table of values. So question for you. If I plug in negative 1, what's the square root of negative 1? Error, I, right? No, square root of negative is I, correct? We're not okay. We're not graphing imaginary, so let's not use negative 1. Let's try 0. What's the square root of 0? Okay, so we're going to start at 0, correct, everybody? So 0. Square root of 1 is 1. Square root of 2 is a decimal. Let's not use that value. We only want nice values. Square root of 3 is a decimal. Square root of 4 is 2. So let's plot those points. That's good enough. 0, 0, over 1 up 1, over 4 up 2. Let's graph this. We are going way slow compared to my other hours. So because we didn't do domain or range on any of those, so I just want to quickly ask you what domain and range is on this. So domain for this was left and right. It's from negative infinity to infinity, right? And our range is the lowest y value to the highest y value. Lowest y value is 0 and goes to infinity. So 0 to infinity, right? Okay. So just look, we'll just talk about the domain and range for this. So of the green function, my domain is still growing left and right forever, correct? So it's still all real numbers. Negative infinity to positive infinity are all real numbers. Our range is negative 3 to infinity, right? Negative 3 to infinity includes negative 3, not infinity, because infinity is not a number. Hopefully. Okay, we're good with that then. Look at the pink one. My domain is still negative infinity to positive infinity. But my range is negative infinity up to 5, right? Okay, then we're good with those. Okay, moving on. So continuing, what is my domain for this parent non-shifted function? My domain is 0 to, does everybody see y? Good, it starts at 0. Our range is, it's y values, don't let it throw you off. 0 to infinity, very good. Now, I'm just going to graph some examples. Just watch, okay? Everybody watch. We're going to go as quick as possible. So what I want you to understand is, so go to 4A and 4B and let's graph these together. So on your notes, flip to 4A. On your notes. So what you need to understand is they're not going to have this listed out for you. But you guys saw how we reproduced that graph, right? And we just plugged in points. So this one is a shift of left 3, correct? So let's do this the easiest way possible. We have this starting at 0, 0. Then we shift back 1, 2, 3, boom. You guys see what I just did? Shifted that point. Okay, then we used to be at over 1 up 1. So we're shifting left 3. 1, 2, 3, boom. Then we used to be at over 4 up 2. We're shifting 1, 2, 3 back. So now we can draw that in. Pretty easy, right? Okay. Yeah, so the domain, I just used my original points and shifted them. And I just did it without actually listing them out. So my domain for this one is negative 3 to infinity. Correct, everybody? Yeah. And then my domain, so don't mess up on range for this one. Range is the lowest y values. 0 to infinity. Way to go, Weston. Good. Okay, let's graph this one. I'm going to put mine on the same graph. So we're shifting just up 4, correct? So wasn't the original point at 0, 0? Up 1, 2, 3, 4. Then this was over 1 up 1. It shifted up 1, 2, 3, 4. And then we used to be at over 4 up 2. We shifted up 1, 2, 3, 4. Questions on that? Okay. Perfect. So let's do this one. Okay, so let's do this one. This is a shift from square root of x, and that's right 1 down 2, correct? So guess where I'm going to start? 0, 0. Isn't that the nice point to start on this one? Okay, go. 0, 0, we go right 1, down 1, 2, right? This isn't on your packet. Just watch. So 0, 0 shifted, right 1, down 2. Everybody good? Originally we were at over 1, up 1, so we're going right 1, down 2. Does everybody see how this is working? Over 4, up 2, right 1, down 2. Pretty easy, right? Okay. For the most part.
Yeah.
Okay, let's move on. No, this one I did want to do. So just watch if you would like. So left 1, up 4. Now watch what happens. So a stretch of 3. So here's the thing. We're going to be stretching 3. So I'm going to start out looking at these real quick. I'm going to multiply all my y values because that's the only thing we change, right, is our y values for a stretch. So wouldn't that be times all of those by 3? And won't we get 0, so xy, so times by 3, times 3, times 3. So these are my new points. 0, 0, 1, 3, and 4, 6. I'm not going to do anything more than that. I'm going to start with those points. So we're at 0, 0, when we shifted left 1, and then up 4. Everybody good with that? Now my next point was over 1, up 3, right? Shifting left 1, up 1, 2, 3, 4. Do you see how that used to be like this? You see how now it's stretched clear up? Does everybody see that? Okay, so, and then we would do the other point. So over 4, up 6, and so it looks like this. So if we went backwards, and I said, given this function, write the equation, do you see how it would be easy to figure out the stretch? You would just look and say, normally it was over 1, up 1. Now it's over 1, up 3. We must have multiplied by 3. So everybody see. Because going backwards is the hardest. Okay, go to your parent function for square root of x. Here we go. Oh, we already did that. Here we go. Go to your parent function for y equals x cubed. Let's plot some points. So, negative 2 to the third power is negative 8. Plug in negative 1. Negative 1 to the third power is negative 1. Plug in 0, we get 0. So you're putting in points. We plug in 1, we get out 1. We plug in 2, we get out 8. So this is back on the parent function page. So let's graph this. Okay, so we're going negative 2, negative 8. Then we're going negative 1, negative 1. We're going 0, 0. So you're graphing this over 1, up 1. We're going over 2, up 8. So this is what a cubic function looks like. You've got to remember what a cubic function looks like because they're going to ask you to go backwards too. So you see what it kind of looks like a snake? Yeah. Domain and range for this is all real numbers. Look, it's growing left and right forever. Our range is it's growing down and up forever. So for a cubic, it's all real numbers, all real numbers. This is the parent function. What I want you to notice is a couple of key things. This is where my starting point is, before the little bumps happen. Does everybody see what I mean? The origin. So from here, normally it's over 1, up 1. So if this was over 1, up 2, wouldn't that be a stretch of 2, everybody? You see what I'm saying? Okay. Okay, let's grab this one. So now flip to 2a. You're going to graph this. So let's do this the quickest way possible. Left 2, down 1. So you got to think in your head, what does this original graph look like? Isn't 0, 0 a point? Yeah. Okay, start at 0. Shift left 2 and down 1. Now we're there. Now you'd say to yourself, my next point was over 1, up 1. We're shifting left 2, down 1. That's going to put me there. My other point on the original function was over negative 1, down 1. We're now shifting left 2, down 1. So I can see what's happening here. Coming up. And then our other point was over 2, up 8. So we're shifting left 1, 2, down 1. Boom. So now I can draw this in. So then our other point was negative 2, negative 8. So it'll be down here somewhere. So it's just a shifted cubic. So if we went backwards, this is where you'd start. This is the hardest part for students. If we were going backwards, we'd say this is a cubic function, but due to the looks. Here is where I usually have an origin. This is where my origin usually is, correct? Then from there, it's still up 1 over 1, so there's no stretch or compression. So we see that. But the origin used to be at the origin, so the origin was shifted left 2, down 1. That's how you go backwards. Everybody good with that? Okay. Cool. So we're good with those. Let's move on to cube roots. We're down to the last thing, and then I'm going to give you time to just start graphing these. Here we go. So y is equal to the cube root of x. Let's plot some points. If you ever don't know what a graph looks like, plot points. So stick with me and I'm going to let you practice. So let's plug in some points. Let's start with 0. Cube root of 0 is 0. Cube root of 1 is 1. What if I plug in negative 1? What's the cube root of negative 1? Negative 1. Now, cube root of negative 2 is a decimal. Cube root of negative 3, 4, 5, 6, 7, 8. Oh, cube root of 8 works with negative 2, right? Cube root of negative 8, so we're going to plug in negative 8. If we only want pretty numbers, we get out negative 2. So plug in 8, we get out, cube root of 8 is 2. Let's plot those points. Go. On your graph, plot them. It looks kind of like the other, but on the side. On its side. Yeah, it looks like that. Plot those points, guys. So do you see how it looks like the cube function like this, but it's on its side? Okay. So notice a couple key things. This is where we would start. So this is our origin, and then we went over 1, up 1. Right? Over 1, up 1. And then, so just if you ever were having to go backwards, you would always start there. You'd start where your origin would have been. Okay, let's graph this one. We'll graph this one, 5A. So just look at this one on your paper and maybe take 1 or 2 notes on this. So we would say left 3, down 1. And a reflection over the x-axis. So this is where I start. 0 will reflect over 0, correct? So now we're going left 1, 2, 3, down 1. You'd plot that point. Then on our parent function, we used to have over 1, up 1, correct? Over 1, up 1. So are we going over 1, down 1 now that it's a reflection? Okay, over 1, down 1. And then now we're shifting it left 3, left 1, 2, 3, and then down 1. So now that became down there. Our other point was negative 1, negative 1. So now we would be we reflected it over the x-axis, so we'd be at negative 1, up 1. So now we're shifting left 1, 2, 3, down 1. Boom. So it's looking like this. So our other point was over 8, up 2. So we're reflecting it. So go over 8, down 2. And then left 1, 2, 3, down 1. So there's my other point. Pretty easy, right, guys? Okay. All right, we're good then. Okay. So what I want you to do is show me that you can do it by practicing. Go to your worksheet, flip to the back, and do 9 through 14, and also say the domain and range. Go. So this is the hardest one for people to watch. Pull yourself away and watch. Going backwards. So first of all, looking at this picture, you should be watching or you will be lost. This is the hardest part for people to do, and the most important. It says write the equation of the function. So this is working backwards. So you have to look at this picture and say, I know what kind of function that is. You've got to get it down in your head. So what function is that? Square root of x, right? You just got you'll have to, I know it because I've been teaching it. So just think in your heads, like you've got to get this memorized. The square root function looks like this. Everybody good. So you would say, okay, a parent function is the square root of x. Correct, everybody. Now think about it. Doesn't a square root function that's non-shifted start at 0, 0, over 1, up 1? Something like that, correct, everybody? Yeah. So do you see how that was shifted? Left 4, up 2. So write that. Left 4, up 2. And then isn't that just everything we were just doing a second ago? Going backwards. Now also you have to check to see if there's a stretch or compression. Do you see how this is over 1, up 1? Isn't this still over 1, up 1? So there was no stretch or compression. So our answer for this would be y is equal to the square root of x minus plus 4, you go opposite, right? And then plus 2. Does everybody see how that works? Okay, look at this one. What kind of function is that? So you have a parent function to go off of. Square root of x. We just did one that looks just like that, you guys. Right? Square root of x. Do we see how this is working? Okay, now it's reflected. Isn't this the normal one? I like to always kind of like draw in what the normal one kind of looks like. So the normal one's facing up. Isn't this reflected over the x-axis? Okay, so just remember there's going to be a negative in front. Now look, normally, now look, this is my starting point now. Then we go right 2, up 4. right? 2 up 4, okay? That's my new starting point. Now, normally, we would go down 1 over 1, right? Over 1 up 1. But are we going down over 1 down 2 now? Look, between, so it's a stretch of 2. So let's write out the equation. Y is equal to negative 2 square root of x minus 2 plus 4. So do you see how I figured out the stretch part? That tends to be the hardest part for people. Normally it was over 1 up 1, now it's over 1 down 2. So does everybody see how that works? Stretch of 2. Okay, looking at this one, you have to remember, this is a cubic function. X cubed, right? So then it was shifted. Normally, it looks like this. Okay, it looks something like that. So isn't that shifted left 4 up 3? Left 4 up 3. Now this is where people always have the hardest time. Is there a stretch or compression? So look at the normal one. It's over 1 up 1. Isn't this still over 1 up 1? So no stretch or compression. Everybody see how to do that. I'm not going to finish writing it out. Okay, I'm looking at this one. It's a cubic again, right? X cubed. This is where it used to start, over 1 up 1, over 1 down 1, like this. Okay, so now I shifted. This is my point, where the origin used to be. So over 2 up 3. So right 2 up 3. Does everyone agree? Now look, normally we're over 1 up 1. So let's go over 1, but now we're up 1, 2. Don't say 3. Look, over 1 up 2. So it's a stretch of 2. Everyone understand? Okay, we're all golden. So we'd be good with this one. Isn't that a cube root? Yeah. Cube root of x. So then normally we were here, up here, down here like this, right? So it shifted. There's my new, where this used to be. So left 5 up 2. And then look, up 1. And this used to be over 1 up 1, over 1 up 1. So do you see how to go about tackling these? Okay, what I want you to do then. Yes.
So like when I said like the
Write the equation. So like that's what we were just doing with these. So see how this is? This is my new origin, correct? Yes. Yeah, they're always originally started doing zero. Okay, what I want you to do is try some on 5 through 8 right now, so that you can ask questions on those if you need. 5 through 8, go.